Okay, so these are some of the worksheets for our measurement topic, and these are what we call composite shapes, which just mean that we're using more than one shape. So we break each shape into its individual parts and then add them together. Sometimes these worksheets are a little bit messy the way that the author likes you to set them out. I don't actually care how you set them out, as long as you sort of roughly show me what you've done and you get the final answer in order. So if we were looking at this one, we've basically got two rectangles. So we've got our first rectangle here on the left, and to get the area of any rectangle, it's basically length times width. And again, it doesn't actually matter which order you multiply things, so it even doesn't matter which order you call, well, they've called length and breadth. It doesn't matter which way around you go. But here, I'm going to just go 26 times my 13. So if I pop that into my calculator, I get an answer of 338. So that first area would be 338 centimetres squared. Don't forget when you're writing an answer, that power of 2 just tells us that it's a surface area that we've found. Okay, then we do the next little one. So the next rectangle that we've got to the right here, we're doing the same way. They've called that A2 in the middle, so they've labelled it over here. As I say, it doesn't actually matter where you set it out, as long as you know how to do it. In a test, I'll just give you the shape and you can show me the working however you like. So over here, we've got 17 centimetres times 12. And again, the order in which you had those wouldn't make any difference, so don't get stressed about which way around you write them. That would give you an answer of 204. And so, of course, the total area is just the two areas put together, so the 338 from the first answer, plus the 204 from the second one. And so when you add those together, you get 542. Let's have a look at another one. Now in this next one, what they're actually trying to get you to find is this sort of area here. But you'll see that in order to find that, what you're actually going to have to do is to get the area of the full triangle, and then you'll subtract the area for the little square that's in the corner. So first we'd start with the area for the full triangle. And a triangle, the formula for a triangle is basically we go a half times the base times the height. So in this case, and it doesn't matter again which one you call the base and which one you call the height. What matters is that your height has to come from a 90-degree angle. So, and then which way around we go, it doesn't actually matter. So here I might be saying, well, it'll be a half times, I'm going to call the base 2.5. That's that measurement right across the bottom. So a half times 2.5 times my height, which was... now it wasn't 1.2, it was actually, I've made a lot of mess here, so I'm just going to rub off all my markings, so sorry, that didn't work. Rub these markings off so you can actually see the diagram again. When you look at this diagram, the 1.2 is just that bit there, and then they've separately told us that this bottom bit is also a 0.6. So because I have to deal with the triangle as a whole shape, so I'm dealing with this whole side, I'll need to add the 1.2 and the 0.6 to get my whole length. So when you add those together, 1.2 plus the 0.6, I'd have 1.8 altogether as that whole length along the top here. So it's the 1.8 that I'd put into my formula. So again, just so that you know the process, it's a half times my base, which was the 2.5 centimetres across the bottom, times the 1.8. So if I put that into my calculator, and again, you know, if we're giving you numbers with decimals in them, then we're going to allow you to use a calculator, so you won't need to do that mentally. So that would give me the triangle is 2.25 metres squared, and then A2 is basically the little square in the corner here. They've told you, and again, I've made a lot of mess on this diagram, so I'll take out some of my highlights here. They've told you with these little marks here that all these sides are the same. So they've only given you the 0.6 here, but that means that this other side's also 0.6. So the area of that square is again length times width. In the case of a square, they're the same. So 0.6 times another 0.6. Or you could have had 0.6 to the power of 2 would give you the same answer, and that's fine, which is going to give you 0.36. So that's the area of the square. So altogether, my area would be the area of the triangle, which was 2.25, take away the area of the square, which was 0.36. I'll put that into my calculator, which would give you an area altogether of 1.89 metres squared. And you can see here I didn't fill in these boxes the way they wanted me to. It doesn't matter how you fill it in as long as you get to that end answer that we wanted. Let's have a look at the next one. Again here, this should be nice and simple. We're going to get the area of the larger rectangle and then take away the area of the triangle in the bottom there. The only thing you have to watch is that once again what they've done here is they've not given you the full length of the rectangle. So when you want to get this length here, you'd need to add this little bit here, which was that section, to the 75 millimetres altogether. So just so that you can hear that again, so 68 plus the 75 would be your length across here. So 68 plus 75 would give me 143 altogether. So for the rectangle, and they've removed the scaffolding now, so you can show it however you like, but I might even put the symbol next to it. So for the rectangle, it's 143 times the height on the other side, and I'll just change colours, so times the other side. And again, I've got to add these up, so that's going to be the 42 plus the 54. So 42, what have we got, plus 54 is going to give me 96. So I've got 143 times 96 altogether. So that's going to give me 13,728. I'm just going to double check that. That sounds reasonable though. Yep. So I've got a total area here of 13,728 millimetres squared. And then I need to remove the triangle. So the triangle is half base times height. So a half times, and again, it doesn't matter which one I call the base. I'll call that bit there the base. So in this case, I'll go a half times 75 and then times it by the height of 42. If you'd reverse those numbers, it would make no difference. So don't worry about which order you go in, as long as you've got a 90-degree angle between them. So that would give me an answer of, for the triangle, of 1,575. So my overall area would be the area of the rectangle, the 13728. Take away the area of the triangle in the corner. So I'll just pop that through. And that would give me an area altogether of 12,153 millimetres squared. Okay, same here. Now, we didn't do a lot of kites actually. A lot of the textbooks don't focus on the kites, but the process is going to be the same. I'm going to get the area of the rectangle. So the area of my rectangle, and I'll draw the symbol next to it so you know which shape I'm doing, would be 62 times my 155. The only other thing I should add here is they've not tried to trick us here. Both my units are indeed in millimetres, but that's the only other nasty thing they can do to you. If your units weren't the same, you'd convert them to make sure they were the same first. In our case, we're all good to go. So when I times that, my rectangular area is 9,610 millimetres squared, always squared if it's a surface area we're doing. And then we have to find the area of the kite. Now, I'm not even sure that we covered the kites because they're not in our textbook. But basically, the formula for a kite, and I'll draw it to the side here. So the formula for the kite is basically, they'll say it's a half times x times y, where x and y are your measurements of the length and the width. And again, it doesn't matter which order that you call that. So my x will just be the length along here, which is the same as the length of that. So for my diamond, I'm going to have a half times 155 times the width of my shape, which was the 62. So it's basically going to be half of the measurement that you had above. So if I put that through, type that into your calculator, this area would be 4,805. And altogether, the shaded area It was the shaded area they want, will be the total area that we found. So shaded area would be equal to the total that we found, the rectangle, so 9,610. Take away the kite, which was 4,805, which should be 4,805 because the kite was the half. So it's equal to 4,805 millimetres squared. Okay, let's go up to this top one. Now, the top one, we've got two shapes here, and these are some of the trickier shapes. So the first one's a parallelogram. Now, your formula, hopefully you've kept your formulas that we did in class, but the formula for a parallelogram is basically just base times height. So, and I might draw that to the side again. So anytime we have a parallelogram, they must be parallel. It's a bit hard to draw. Then it's basically the area is equal to your base times your height. So in this case, my base was 3.7, and you can see that across the top there. And my height must be this vertical height here, which they've given us here. So I'm timesing that by the 1.2. That's going to give me the parallelogram. So 3.7 times 1.2. That gives me an area of 4.44, and that was in metres, so metres squared. The second shape is one that everyone always misses, and it's a trapezium. So you can see here, this second shape there. The formula for a trapezium, and I might put that underneath here, so I'll put it inside actually. The formula for our trapezium, if you kept your notes, was A plus B divided by 2 times your height. Now what you need to remember is what the A and the B are. So the A and the B were the two parallel sides. So when I'll remove all my highlighting so far, so you can bear with me here. So put this back on. So my two parallel sides, I'm looking for these markers, which is these little double arrows. My two parallel sides are those two. And what we can see is this top one, even though they've not marked on it, is the same length as the line above it. So I can see that this one's also going to be a 3.7. So when I come to find that area, and I do that A plus B business, my A would be my 3.7 plus my 5.3. And again, it doesn't matter which one you call A, which one you call B, as long as you've added the two parallel lines. Divide that answer by 2. And you can use your little fraction button on your calculator to achieve that. And then times that by your height. And again, like all of these questions, your height has to come off of a 90-degree angle. So my height is this line here. Sometimes they'll give you this slopey line instead. That's not useful. So that's a trick if they ever do that. So it's that height there, which is my 4.1. So I'm going to times that answer by 4.1. So I'll just pop that into my calculator. So don't forget the brackets. If you don't use a button, a three-dimensional fraction sort of button, then sometimes you'll get a nasty BIMDAS error. If you you will get a nasty BIMDAS error if you don't remember to put the brackets in, if you're not in a two-dimensional button. So pop those in. But otherwise, you just type that into your calculator, and you would get an answer here of 18.45. And that was in metres, so metres squared. Now, that was for the trapezium, so your total area will just be the two areas added together. So that was the 4.44 from the first shape, plus the 18.45 for the second shape. So if I add those together, you would get an answer of 22.89 metres squared altogether. Okay. Next one's nice and simple. So the next one we've got basically a rectangle and then your three squares. So to get your first area, and they've got lines all over the place, it doesn't matter how you show you're working, but my first area, so my big rectangle, will be equal to my 18 times my 42. So put that into my calculator, that's 756. And this was measured in centimetres, so my answer will be in centimetres squared. And then I need to subtract each of the squares, and all the squares are the same, and we can see that because they've all got these same little markers, and they indicate that my measurements are the same. So each square, I'll do them separately, each square is going to be equal to 11 times 11, and so each square is 121, and I've got 3 of those. So basically, if I times that by 3, that tells me that all of my squares together would be 363. So my total area is going to be equal to the 756 from the big rectangle. Take away my 3 squares, which were 363 altogether, or 121 each. So they've done the 3 times what they've done there. They've just written it's 3 times 121, but we already did that up here. So it doesn't matter which way around you went, as long as you get to the end point. So 756 take 363 would give me an answer of 393. And again, that was in centimetres. So my answer will be in centimetres squared. Next shape, there's a couple of possibilities here. The easiest one is probably to treat this as one big rectangle here, and then the smaller rectangle underneath it. So I'll go into a different colour here. Okay. I could, there's other options though. If I remove my highlights there, I could also, oopsies, so I'll leave that one. I could also have made one rectangle here, and then I could have done 2 squares over here, and then another rectangle in here. It doesn't matter which way you go, just make your life easy and pick the biggest ones that you can generally. So if I started with that first one, I can see that that's 4.4 metres long, and oopsies, don't forget my decimal, so 4.4, and each rectangle is your length times your width. They haven't told you the width, but what they've told you is that this whole measurement here is 2.1, and they've told you that these two are the same, so it must be half each to get that individual measurement. So if you go 2.1 and halve it, so dividing by 2, that means that each of those lengths there have to be 1.05. So, oopsies, that's a 0. Make sure you can read my writing. I'm a little bit rough. I'm still rough, there we go. So 4.4 times 1.05 to get my blue rectangle. So 4.4 times 1.05 is going to give me 4.62 for the first one. And the bottom one, first of all, I have to calculate this measurement across the bottom here. Now to get that, what I can see, the information that I have is that I've got this full length is 4.4. So I'm going to go 4.4, and then I'm going to take away the 2 little sides here that I don't have. And each of those sides, because I've got the same marker as there, is 1.05. So I'm taking away 1.05 to remove this first side, and taking away another 1.05 to remove that. And that'll give me that total length, which is 2.3. Okay, so that gives me there. So my second rectangle, and I'll just highlight that for you. So the second rectangle here is that 1.05 times that 2.3 that we just calculated. So 1.05 times 2.3 is equal to 2.415. And of course your total will be the sum of those 2 rectangles. So the 4.62 that we began with plus the 2.415 there. And that will give me a total of 7.035. Okay. Now this one's just getting nasty, isn't it? So now it looks horrible, but it's not nearly as bad as it seems. So if you looked at this one, what we've got initially is a great big trapezium. So that's going to be that trapezium formula, the A plus B. I'm going to write that down again for you. So the trapezium is A plus B. A and B are your 2 parallel sides. You divide those by 2. What that's effectively doing is turning your shape into 2 triangles. That's the reason why we're doing it, for those who remember. And we times that by the height, which must be a vertical height. So we'll be looking for this height up and down here. So now we just need to find all that information. So the parallel sides are nice and easy to find. So we've got our A and B is 120 and 172. So I can see that there. I'll change colours. So my parallel lines are this top and bottom one. So I've added those 2 numbers there. And I divide those by 2. And then I have to times it by the height. So what I need is this overall height all the way from the top down to the bottom. Now, they haven't given me that directly, but what they've told me, I'll just change colours again, shall I? They've told me the height of these are all 84. So I know that I'm going to have the 84. I'm going to need to put a bracket around this. Plus I've also got this extra bit on the top and the bottom here. And they've told me over here that each of those are 10 millimetres. So I'm going to add another 10 mils from the top and 10 from the bottom all together. So 80, 90, 104 altogether would have been my height of this shape from the top to the bottom there. So if I put all that into my calculator, and it doesn't matter if you calculate those separately first or not, it will all work. So over my 2 times, and I'm just going to type mine into the calculator exactly as I see it. And so what we've got there, we will wind up with an answer of 15,184 millimetres squared. Now that's that great big trapezium only. I've probably used up a fair bit of my working space. And from that I have to take away the triangle, and I might leave you to do that because that's relatively easy. So you've got one triangle here, and they've given you those dimensions, so that's going to be a half of 84. So I'm going to say take away a half of my base times height. I've gone height first, it doesn't matter which order. And my base there, they've told me that was equal to, that's got the same symbol as this one, so that's 103, so times my 103. That's my triangle. You'll need to calculate that and subtract that. And then of course you've got another triangle, which is actually identical, so you can just take away that answer twice and you'll be done there. Let's have a look at the next one, because otherwise these videos get a bit too long to load up.